All right, these are problems 1 through 5 on review day number 6. First, this was the 2018 practice exam, so the one from last year. And it says function f is given by this. What does f prime 2 equal? So just some basic derivative stuff would probably help to rewrite that as 4x to the negative 1. And so then when we take the derivative, it's going to be negative 4x to the negative 2 plus 5. And then they want us to put 2 in there, so it's going to be negative 4 times. This negative 2 means it flips over. So we'll have 2 squared plus 5. So this is negative 1 plus 5, which gives us 4. And so we end up with A as the answer for that one. All right, not too bad. Good start. Number 2 gave us the integral of 6e to the 3x. One way you could do this is to remember that whatever you write down, if you take the derivative of that, it should get you back up to here. And so if I were to take the derivative of 2e to the 3x, it'd be 2 times e to the 3x times 3. 2 times 3 would give me 6. C, it goes away. So you could do it as simple as that, or you can do a u sub u equal 3x, du equal 3 dx, and then dx equals du over 3. And so we'd have the integral of e to the u times du over 3. That divided by 3 comes out. 6 divided by that 3 is 2. Integral e to the u, which gives you 2e to the 3x plus c. Okay, so a couple ways you can do it. Again, it's kind of up to you. Number 3 gives us a graph, and they say what is the limit as x approaches 1. So as we approach 1 from the left, we're going to a value of 3. As we approach 1 from the right, we're going to a value of 1. So we have a jump discontinuity here. Because of that, it doesn't equal 1 or 3 or any of those. It does not exist. So usually this is not a good one to guess, but in this case we know for sure that that's what's happening there, and so that's our answer. For number 4, they give us a derivative. They tell us that f of 2 equals 3, and they want to know what f of 1 equals. So a couple different ways that you can do this. We can say that f of 1 would equal the value we know, which is 3, plus from that time 2 to the time that we want, 1, the integral of the rate, which was 3x squared plus 2x. Okay, and so this is going to be 3 plus, integrate that to x cubed plus x squared, and we're going to evaluate that now top minus bottom, so it'll be 3 plus 1 cubed plus 1 squared, so that's 2, minus 2 cubed plus 2 squared, that's 8 plus 4, 12. So 5 minus 12 gives us a negative 7. You could integrate this and get a general f of x with a plus c, then find out what c equals and then plug 1 in. Should give us the same answer. That's another option. All right. And then finally number 5 here gives us a table of values. And it says using a right-hand Riemann sum with 3 subintervals, what's the approximation number of people who leave the building the first 15 minutes. So we're doing a right-hand Riemann sum. Again, it might help you to graph this out. So we're at 100 for 0. We're at 100 for 5. At 10, we're at 75. And at 15, we're at 55. All right, and we're using the right-hand Riemann sum. So we're using the right side of these subintervals in order to make this happen. And so 100 times 5 is 500. 75 times 5 is 375. And then 55 times 5 is 275. So if we add that all up, we'll have 150, 12, 50. Nope, that's not one of my choices. It should be 1150. Accidentally added too much there. Right. And that's 1 through 5.